All right, so we just got done doing all the derivative rules. So power rule, quotient rule, chain rule, all the trig derivatives, all of that. Now we're going to do what's called implicit differentiation, which is used when y is not in terms of x. So what that means is if y is in terms of x, you have y equals and then a whole bunch of x's. So if y is not in terms of x, you have x's and y's all jumbled up. Essentially, if it looks like a disaster, that's when you need implicit differentiation. If you look at it and go, oh, wow, this is crazy, then you're going to need implicit differentiation. And also what I tell everybody is if your answer looks like a complete disaster, you probably did it right. Okay, your answer should like not be nice looking. It's going to be a mess because the problem's a mess. And what you have to remember is chain rule. So when you take the derivative of y, so just y, when you take the derivative of y, you chain on dy dx, which is the derivative of y with respect to x. Why don't you need to chain anything on when you take the derivative of x? Because x is the independent variable. We want y in terms of x. It's just it's not, they're all jumbled together. I usually get asked, hey, Ms. Cole, can I write y prime instead of dy dx? Technically, yes. Dy dx and y prime mean the same thing, but here's why I recommend against that. These are gonna look like a disaster. You're gonna have x's and y's and dy dx's all over the place. If your y prime looks kind of like a y, you're going to mix them up. So you're better off putting dy dx. All right, so for this first one, derivative of 3x squared, that would be 6x. You're not doing anything different. It's still a derivative as normal. This next term, again, power rule, just like usual, it's going to be minus 4y, but since you're doing a derivative of y, you're going to chain on a dy dx. So it's minus 4y dy dx equals, and then derivative of just x is 1. That's the easy part. Just taking the derivative, the calculus part is easy. Where everybody gets tripped up is with the algebra, because what you have to do now is get dy dx alone. Okay, so this is where everybody has trouble is with all of the algebra. So to get dy dx alone, we're going to subtract over the 6x. All right, so we subtracted the 6x over. I did a copy error. Do you guys see that there? Let me fix that. Copy errors are the worst. It's where you just copy to the next line incorrectly. Like such a bummer, right? Because you know exactly what you're doing. You just copied it wrong. But did you see how what I forgot to write was the dy dx? If you forget that, you are going to catch it. Because what I get a lot is people are like, I'm scared I'm going to forget to write the dy dx. You will catch it because dy dx is your answer. And if that's missing, you're going to be like, oh, I'm missing my answer. All right, and then the last step would be divide over the negative 4y. So this is your answer. And again, it's going to be a jumbled mess of x's and y's, because if the problem is like that, then the answer is going to be like that too. So number 2 says, write the equation. Oh, what 2 things do I need in order to write an equation? Point and slope. So I'm just going to write it out blank. We need a point, we need a slope at x equals 1. So that's our point of tangency. To get your y value, you're going to plug 1 into the original problem. I was piggybacking off of question 1, so we're going to reuse question 1. We're going to plug 1 in for x in the original problem, so just what's printed on the paper. So if you plug 1 in for x, that's going to give you 3 minus 2y squared equals 1. And we're just going to solve that for y. So you would subtract over the 3, gives you negative 2. The negative 2's cancel, so you get y squared equals 1. So what is y going to be? Good, it's going to be plus and minus 1. So there's actually going to be 2 answers. So I'm going to have 1, 1, and we're going to get a slope for that. And then I'm going to have 1, negative 1, and we're going to get a slope for that. There are actually 2 equations that we're going to write. All right, so let's get our slope for this point. So 1, 1. Slope comes from the derivative, so we're going to plug in 1 for x and 1 for y in this derivative. So that would be 1 minus 6, so -5. And if you plug in 1 for y, that would be -4, negatives cancel, so 5/4. So for this point and this slope, we're going to write our equation. Y minus 1 equals 5/4, parenthesis, x minus 1. And then we're going to do the same thing over here. We're going to plug this point into our derivative. Again, slope comes from the derivative. So we're going to plug in 1 for x. That, again, would give you 1 minus 6. That would be -5. But this time we're plugging -1 in for y. So -4 times -1 would just be 4. So -5/4. And so it's going to look almost the same, except we have some differences in the signs here. It'll be y plus 1 equals -5/4 x minus 1. So we ended up with 2 answers there, which is kind of cool. And you'll notice one of them is at the point 1, 1, and one of them is at the point 1, -1. You might be like, oh, well, that's not a function. That would fail the vertical line test. But whenever your x's and y's are all jumbled up like this, they aren't necessarily functions, but that's okay. We aren't needing them to be. All right, and the rest of these, we're going to practice finding the derivatives. All right, so derivative of 5y, that would be 5 dy dx. Again, every time you do a derivative of y, you need to chain on a dy dx. Plus, all right, here we have x, y. What rule is that going to be? That is product rule, right? So product rule is the first thing, so that's x, times derivative of the second. So derivative of y is dy dx. Again, it's derivative of y with respect to x. So first times derivative of the second plus the second times derivative of the first. Derivative of x is just 1. If you don't want to write it, that's fine. I just put it in there to show you the pattern. And then equals 2x. That's the calculus, which honestly, that's the easy part. Now we have all the algebra to do. You have to get dy dx by itself. Both of these terms have a dy dx, so we're going to leave them where they are. This is going to get subtracted to the other side. So when you subtract that over, it'll be 2x minus y. And then for what's left, since they both have a dy dx, you can factor dy dx out. So what would be left if you factor dy dx out of those two terms? Yeah, good. 5 plus x. And then we're going to divide that to the other side. So your final answer would be dy dx equals 2x minus y over 5 plus x. And again, if you get a jumbled mess that looks like a disaster, then you probably did it right. Because they're not going to be nice, neat answers. All right, this is going to be a chain rule. It's like sine got hungry and ate 4x squared. All right, so derivative of the outside. What's your derivative of sine? A good cosine. Leave the insides alone. Cosine of 4x squared. Then you're going to chain on the derivative of 4x squared, which would be 8x. I'm going to go ahead and put that out front as the coefficient, just because it'll look a little bit nicer that way. So 8x cosine of 4x squared. Minus, all right, derivative of cosine is negative sine. So the negatives are going to cancel. This will be plus, and I'm going to leave a little space here, sine of 5y. And then we're going to chain on the derivative of 5y, which would be what? Get 5 dy dx. So I'm going to put the 5 out front and the dy dx at the end. Equals. This is the most commonly missed thing with these questions, is that people will write equals 9. You have to remember that you're doing a derivative. So what's the derivative of 9? 0. So just remember that, like, I know that's such a silly little thing, but I'll tell you, like, one of you will probably do it. Okay, be careful. Yeah, you'll do what? Yeah, well, just in advance. Just try not to let it happen to you. You're going to be bummed if you do. Derivative of a constant is 0. And then we want to get dy dx alone. So we're going to subtract over the 8x cosine of stuff. So if you subtract that over, it's going to be negative. And this is everything that's left. And then you're going to divide everything else. So you have dy dx equals negative 8x cosine of 4x squared over 5 sine of 5y. We're hanging in there? We okay? Everybody's good. Okay. Do you want to try this one on your own? Here, everybody try this one and then I'll go over it. All right, let's see how this went. For 5e to the y, what did you put for that derivative? Yeah, perfect. It's itself, and then you just have to chain on derivative of y, dy dx. All right, plus 3 equals dy dx. All right, what's a little tricky about the algebra, that's the end of the calculus. What's a little tricky about the algebra is you have two terms with the dy dx, and they're on opposite sides of the equal sign. So the first thing you have to do is get those on the same side. So I'm going to subtract over the 5e to the y dy dx. And now I have them on the same side, so what can I do? Good, factor. Also a little tricky here, when you factor that out, what's left from the first term? Good, 1, and then minus 5e to the y. And then you're going to divide that over. How did that go? Thumbs up, thumbs down, sort it in the middle? We got, no? Can I clarify anything about it? Is the first line going okay? Because like if you got that, you've got the calculus. The rest of it's algebra, and I know it just kind of like looks scary. Yeah, that's what it always is. That just comes from practice. But let's try another one. All right, x to the 4th. That'll be 4x cubed. All right, 10 ln of y. The derivative of ln of y would be 1 over y. I'm just going to write it as 10 over y because there's a 10 there. And then times dy dx. So it would be, again, it would be 1 over y. There just happens to be a 10. So 10 over y dy dx plus, all right, what would come next? Good, 2y dy dx. And then derivative of 0. But there could have been any number there. It could have been 47 million. The derivative would still be 0. All right, so these two terms have a dy dx. I'm going to leave them where they are. I'm going to subtract the 4x cubed over. We're going to subtract that to the other side. So that's gone. That's taken care of. And then we're going to factor dy dx out of what's left. And so that would leave us with 10 over y plus 2y. And then to get dy dx alone, you'll just divide that stuff over. So your final answer will be negative 4x cubed over 10 over y plus 2y. And I realize that there's a fraction within a fraction, but that's okay. Again, it's not going to be pretty. So you just kind of have to accept that. Oh, and we talked about this notation the other day. What does this mean? Second derivative. All right, so you're going to get the first derivative and then do it all over again. All right, so first derivative, this would be 3y squared dy dx equals 2x. And then you'll divide the 3y squared over. So that is your first derivative. And now we're just going to go one step further. Now we're going to do a second derivative. So since this is a fraction, what rule are we going to need for this? Quotient rule. So quotient rule is the denominator. So it'll be 3y squared times derivative of the numerator. That'll just be 2 minus the numerator. And then times derivative of the denominator. All right, what is that going to be? Yeah, perfect. 6y dy dx and then over the denominator squared. Now I'm going to clean this up a little bit just for the sake of practicing simplifying things down. And the other thing you have to do is you have to replace the dy dx. You can't leave that in there. So what does dy dx equal that we'll replace it with? Yeah, like this right here, that's going to have to get substituted in for that. So let's see, we can clean this up a little bit. This would be what, 6y squared minus 12xy. And then in place of dy dx, I'm going to put this. Don't make me say it again. All of that. And then over, if we square this, that'll be 9y to the 4th. You could keep going and simplify that down more. If it was multiple choice, you would have to, because they would keep going until the very bitter end and keep simplifying things down. I'm fine with you leaving it like that. But it's mostly algebra. I'm going to give you guys one more to try. We'll just call this number 8. I just want you guys to practice another one. So I want you to find the derivative at the point 1, 3. Try that one. Talk to each other. Like, I got this. What did you get? Or this was my first step before you move on to the next thing. But I want you to find the derivative at that point, and then I'll go over it.